Welcome back to Math 109, Plain Trigonometry. In this video, we're going to take a look at the operations on the complex numbers. So we'll start with addition. So if I give you a plus bi plus c plus di, I'm just going to add these just like I would with a polynomial and variable I. So we get a plus c plus b plus d multiplied by I. So just adding them like they're polynomials. Same thing for subtraction. A plus bi minus c plus di. I subtract the real parts, subtract the imaginary parts, so I get a minus c plus b minus d multiplied by I. Multiplication, again, is going to be just like with the polynomials. We're just going to have one little thing to deal with. So if I take a plus bi times c plus di, so I'll first go ahead and multiply these like we would polynomials, so that'll be FOIL. So I get AC plus ADI plus BCI plus BDI squared. Now the important thing that's different here is that I squared is equal to -1. So we get AC plus ADI plus BCI minus BD, and then rearranging it and putting in the format we had before, get AC minus BD plus AD plus BCI. So now the last operation we need to deal with is division. But before I do that, we're going to define the complex conjugate. The notation for that is we take a complex number and put a bar above it. So the complex conjugate of a plus bi is simply going to be a minus bi. You'll take whatever sign's on the imaginary part of the number and reverse it. Now the important thing with this complex conjugate is that if I do a plus bi times a minus bi, it's going to equal a squared minus abi plus abi plus b squared, technically minus b squared I squared, but since I squared is -1, we can make that change. Well, now minus abi and plus abi cancels out, so I'm left with a squared plus b squared, which is a real number. So it's going to be multiplying by the conjugate of the denominator in both the numerator and denominator. That's going to be key to solving these problems. So this one, rather than giving you a formula, I'll give you an example. So if we take 3 plus 2i divided by 5 minus I, first thing we're going to do is multiply both the numerator and denominator by the conjugate of the denominator. So that would be 5 plus I. So 3 plus 2i times 5 plus I over 5 minus I times 5 plus I. So in the numerator, I'll go ahead and use FOIL. So 15 plus 3I minus 10I minus 2. And then my denominator, I'm going to go ahead and use the formula that we derived in the previous step. So it's 5 squared plus 1 squared, or 25 plus 1. I'll now combine my like terms. Oops, I made one mistake here. I said 2i times 5i is minus 10i. That should have been plus 10i. Minus 2 is correct. It's plus 2i squared, which becomes minus 2. So I end up with 13 plus 13i divided by 26. I can take out a factor of 13 and get 1 plus I over 2. I am perfectly fine with this answer. However, my math lab is going to insist on you actually putting a number plus a number multiplied by I. So it's going to insist on 1/2 plus 1/2 I. So those are your operations on complex numbers. So now that we've established what's going on in the algebraic sense of the complex numbers, in the next video, we're going to take a look at complex numbers from a trigonometric standpoint.